Yes, students, today's topic is insertion sort. You have already seen the selection sort. This is also a similar type of sorting with some differences. So this insertion sorting, first of all we will see some properties of it, and after that we will implement it, and after that we will see the algorithm for it, and finally we will analyze the complexity for insertion sort. Okay, first of all we will see the characteristics. The characteristics of insertion sorting are, first is insertion sort is a simple sorting algorithm that is appropriate for small inputs. If we have a small number of inputs, then the appropriate algorithm which we want to implement for the sorting process, so the selection should be insertion sort. We should select insertion sort for the small number of inputs. Okay. Second property, like in selection sort which we saw previously, sort, the list is divided here also into two parts, that is sorted and unsorted. Okay. Now the third property, in each pass the first element of the unsorted list is picked up transferred to the sorted sublist and inserted at the right place, or you can say appropriate place. Fourth point, for the fourth characteristic, a list of n elements it will take at most n-1 passes. Okay, so we will see it with the help of an example. So we have example, this is 10, 20, 30, 40, 15, 50, 60, 70, 5, 25. This is the unsorted list. We want to sort it. Now we are going to apply insertion sort in it. So the process will start with the previous methods also. We will divide this list into two parts, sorted and unsorted. Okay, so this is whole unsorted part and this is sorted. At this time sorted is 0. Okay, so first of all the first element we will pick and transfer to the sorted list. Okay, 10, this is sorted part, and this is the imaginary wall which will divide the sorted and unsorted. 20, 30, 40, 15, 50, 60, 75, 25. Okay, after that 10. Now now we are picking the element from the unsorted list. This is unsorted list. So the first element will be picked, 20, and will be placed in the sorted list at appropriate place or right place. Okay, so 20 will be placed here, so 20 will placed after 10. Okay, 30, 40, 15, 50, 60, 75 and 25. After that we will pick 30 and 40 because these two elements can be placed as it is. So 10, 20, I am skipping the passes. Okay, 30, 40, I have skipped 2 or 3 passes. 50, 60, 75, 25. Okay, so now the 15 came. Now we will deal the 15. 15 cannot be put or cannot be placed at this place. Okay, so we want to insert it at appropriate place, so that is why this algorithm is called insertion sort. So 15 will be placed here. It will check with this 15 with this. It cannot be placed here. It will check 15 with this. 30, it cannot be placed here. 15 will check with this. It cannot be placed here. 15 will check this. It can be placed between 10 and 20. So 15 will be placed here. Okay, 50, 60, 75, 25, 10. Now 50, 60, 70 will be placed after 40. So I am skipping 3 steps. Okay, 20, 30, 40, 50, 60, 70. Okay, so the unsorted list have the front element or the first element 5, which we want to place in the sorted element or in the sorted list at appropriate place. So we will check here. 5 will be checked with 70, 60, 50, 40, 30, 20, 15 and 10. All the condition will be false, so the true condition will be here. Okay, 5 will be placed here. 20, 30, all this list will be copied as it is. Okay, now we will check 25. 25 will be checked with this and this. So 25 can be placed between 20 and 30. 5, 10, 15, 20, 25, 30, 40, 50, 60, 70. Okay, so this is the answer here. Now we will see the algorithm for that. Algorithm insertion sort. We will pass a, that is array, and n, the number of elements. Okay, so we will start the loop for I is equals to 1, 2 and minus 1, step plus 1. So here we will take a temporary element for the swapping. Here we are taking a temporary element for the swapping. We will keep the first element of array here. Now we will again start the loop for j is equals to I, this I, okay, to 0 and temporary less than a j minus 1, okay. And the step for the loop will be -1, okay. So we will assign the value a j is equals to a j minus 1, okay. These are the insertions. We are backtracking the elements, okay. A j is equals to temp, that is temporary. The loop, this loop will stop here, and this loop will stop here, and this algorithm will stop here, okay. This is the algorithm for that. Now we will see the complexity of it. Complexity, you can see two loops are there, okay. If we take this any steps, and if we take this any step, okay, and comparison are also there. Assignments comparison assignments are there. So the complexity for the insertion sort will be n into n, that is n square, okay. So this is the topic. Thank you.